Now we are going to ask, what is the optimal labor income tax that the government could enact? Now, the first question you should be asking is optimal with respect to whom? And when economists specify this problem, they normally introduce a motive, a goal, a function measuring how good the social outcomes are. And what we're going to do is we're going to assume the following. We're going to assume that people, suppose that is the case that people have preferences, and I'm going to denote now these preferences by B of I, not by U, of Q, L, and M, just as before, but also over the distribution of income. They care about this distribution of income. That take the following form, is equal, just as before, as Q minus L squared over 2 theta I plus M. And then they have this term that is going to be minus sigma square root of the variance of the income distribution. Let me use a different I so it's not confusing. So it's the variance over the i's, where sigma is a constant greater or equal than 0. And here we can call this the basic utility, the UI term, and this is the inequality preference. Let me highlight the intuition of these preferences. If sigma is equal to 0, these are just as before. What we have done is that in addition, when sigma is greater than 0, people derive this utility. They are worse off if there is an unequal distribution, and the higher the inequality, the higher the utility penalty that they get from them. Now, based on them, now we can write, notice also, sorry, that this depends on the type of the individual, the theta I, but this term we have assumed just for simplicity that is the same for every individual. Nothing that we're going to derive really depends on that. Now, the optimal tax problem can be written as maximize over tau greater or equal than 0, the sum over I of the BI's, this big utility function, as a function of tau. So we've seen before that as we change tau, we change the allocation, we change the incomes, we can plug this in every BI, and we want to maximize the sum, the total utility in society, as a function of the tax. And also to give you a high level intuition, notice that this term is very important because it's introducing an explicit motive for redistribution. And we're going to see more specifically how that matters soon. Now, in this problem, notation can get unwieldy very quickly. So to keep things simple, I'm going to use the following notation that I'm going to write here in a box. UI of tau and BI of tau are just basically the utilities as a function of the tax. How do we know the function is the one that we derived in the previous video? I'm going to write by n of tau, the number of theta, the number of consumers with type theta. It could be 0, it could be a positive integer. And then I'm going to write by I theta of tau, what is the income after tax, or the total income after tax, of a type theta, as a function of the tax. This is really going to simplify the notation in a second. Now, the big picture, what we're going to do next is to rewrite the objective function of the optimal tax problem, trying to simplify it, where a lot of the inputs are going to come from what we learned in the last video. So let's start here. We know that the sum of the BI's as a function of tau is basically going to be equal, by definition, to the sum of the UI's as a function of tau minus C sigma square root of the variance of this I theta of tau. Okay. Now, where does this term come from? This is just add the first term of the utility functions. This is the second term of the utility functions. That is c times the basic term, because everybody's preferences are the same. Now, we can rewrite this as follows. And remember, this is just recall, that the income of theta as a function of tau, we proved that last video, is 1 minus tau squared w squared theta I plus tau 1 minus tau w squared theta bar, and we also know that w is equal gamma in equilibrium. Okay, so let's rewrite what these utility functions are. We proved last time that that was equal to, for an individual of type theta, it will be equal to w squared 1 minus tau squared theta divided by 2 plus tau 1 minus tau w squared, the mean theta. This first component was the after-tax income minus the effort for an individual of type theta. This is the transfer. And we have to add over consumers, but instead of adding over I, we're going to add over theta. And we're going to count however many individuals of type theta there are, and we are adding. And that is equal to this term. And then what we're going to do is we're going to do some algebra there. And we're going to say this is equal to minus c sigma, the square root of the following. Let's substitute what the variance of I theta is. That is just basically the sum over n theta I theta of tau minus the mean over all of this square. Please let me emphasize this term is the mean I theta tau value, and this has to be divided by c. Okay. Please notice that the reason we divide by c is because this thing within the square root sign is just follows directly from the definition of the variance. Now let's look at this term for a second here on a side. What is I theta of tau minus I theta tau mean? If you go up there, what you see and you do the algebra is that this is just equal to 1 minus tau squared w squared theta I minus theta mean. But this implies that this term in the top, the sum of n theta I theta tau minus I mean theta tau square, is just equal to 1 minus tau to the fourth, w to the fourth, the sum of n theta theta I minus theta bar square. Okay? And if we divide this by z, and if we multiply this by c and divide it by c, then we get that this is equal to 1 minus tau to the fourth w fourth, the variance of theta times c. Okay? Now we can go back and replug and do some simplification. This is going to be equal to, first let me do some algebra here, w squared 1 minus tau squared theta, divided by 2 times the sum of theta and theta. This is just this first term. But think about what this is. This is just equal to c times theta bar, the mean theta times the number of subjects. of consumers, plus tau 1 minus tau W square theta bar times sum of m theta. But let's think about what that is. That term is just equal to Z, the number of consumers. And then we can finally substitute that term for that, and we get minus C sigma, sorry, this fourth has to be outside, 1 minus tau square W square standard deviation of theta. Remember, the standard deviation is just the square of the variance, and it's also a measure of dispersion in the distribution. Now, this is going to be linearly proportional to, doing a tiny bit of algebra, W square C theta mean that multiplies 1 minus tau square plus 2 tau 1 minus. I know that the algebra is a little bit messy, but there is no way around it. You need to do it on your own piece of paper to check it. Here I'm just highlighting the key steps. Sigma, standard deviation of theta divided by theta mean. Notice that this statistic is still a measure of dispersion. Now, the maximization problem is not gonna, a solution to this is gonna be equal to the solution to this, and we can take this out, and this is gonna be for the equivalent to the solution to, with doing a little bit of algebra, the maximization problem of maximizing 1 minus tau square minus 2 1 minus tau square sigma SD theta divided by theta mean. So now we have simplified the objective function into something really tractable, and we're ready to solve the problem. So given all of the really boring algebra, but very useful, that we have done, we can rewrite the problem as maximize over tau greater or equal than 0 the following objective function that we just derive as a simplification. Now, notice that we saw before by the Laffer curve that this problem, it was going to have a unique maximum. So we can just take the first order conditions, which are going to be necessary and sufficient, and we're going to get that they are minus 2 tau plus 2 1 minus tau sigma SD theta divided by theta mean equal to 0, and we get that the optimal tax is equal to sigma of SD theta divided by theta bar over 1 plus sigma SD theta divided by theta bar. Now we have a precise formula for the optimal tax. And not only that, we have a formula that is quite intuitive, and let's see why. Let's check our intuition. What happens when the individuals do not care, so check intuition, at all about redistribution? That is, when sigma is equal to 0. They don't care about inequality. This formula tells us that tau optimal should be equal to 0. Similarly, when there is no inequality because the standard deviation among the thetas is equal to 0, which also kind of makes sense intuitively. Now, what happens as sigma goes to infinity? Well, as sigma goes to infinity, this tax goes to 1. There is full redistribution, and the idea there, even though by the Laffer curve it's becoming really, really wasteful, and the idea there is that if sigma is very, very large, the payoff of the individuals place so much weight or so much utility on inequality that they are willing to tolerate a lot of efficiency losses. Let me emphasize this point because it is important to really get in the intuition of the solution. as we move from tau 0 to 1, passing through 1/2, we saw that we got a Laffer curve that kind of peaked at 1/2. This is the Laffer curve. Okay. Now we also know that inequality decreases throughout the tax range. Okay, we saw that. So this is inequality, which is variance in income. So what happens is that when sigma gets very large, intuitively makes no sense to move in this direction because you start raising less revenue that you can use to redistribute. But if sigma is very, very large, if the dislike of the inequality of income is very large, the optimal tax problem may push you in this regime, even though it's costing you a ton. I mean, this is so inefficient that you're raising less revenue than you could. You keep pushing this way because you want to reduce the inequality that you really dislike. That's the intuition. Let me conclude with several remarks. The first one is kind of a high-level overview or a big picture that I want you to see. This has been a complicated exercise spanning, or that we have derived spanning 2 videos, perhaps the longest chain of reasoning in the course, and I want you to make sure that you don't lose track of the big picture. So the nature of the exercise is this: you're going to maximize over tax greater or equal than 0 some of these BIs of tau, okay? And these BIs of tau, let me write them down, is the sum or the individual utilities plus this measure minus this measure for the state for inequality of income that we assume may be what people care about. So we're maximizing total utility given that. Now, when you are maximizing the problem, there is a fundamental trade-off that needs to be balanced, which is, on the one hand, you want to increase tax to reduce inequality, and that pushes you to increase the tax. On the other hand, you want to avoid inefficiencies, deadweight losses, that this pushes you to a lower tax. And you need to balance these 2 things in this fundamental trade-off. Notice that the formulation of the problem that we have done solves this trade-off. How? When we are solving the problem, we use the formulas for the income as a function of the tax and the utility as a function of the tax. In other words, we are taking into account how the tax is distorting the behavior, introducing inefficiencies, and maximizing the optimal total social utility, given how people care about inequality. That balances that trade-off. So this formulation of the problem is tackling this precisely and head on. The second is a comment about robustness. Are the fundamental insights robust? The answer is yes, although the details change. So if you write a more complicated model in which there are what are called general equilibrium effects, the tax can affect the prices, etc., the details of the formula are going to change, but the basic logic of the problem is very similar. And the third thing that I want to highlight is that solution depends on objective function in the optimal tax problem. In particular, I want you to notice that we have specified here, we are maximizing sum of total utility, given that people have a very particular form of what are called social preferences. They do not care about others' utility, for example. They care about the level of inequality in society. Somehow they dislike unequal societies, and that led to the formula that we have seen. In problem set 6.1, I'm going to ask you to derive the optimal tax formula under a slightly different objective function of the social preference, and you will see what happens. So the solution critically depends on the objective function, and one naturally source of argument is going to be what is the objective function that should be used to derive the optimal solution. And the fourth thing I want to highlight some key empirical parameters that if you wanted to bring this to the data, you would need to worry about. One is these measures of inequality, which in our model was given by the standard deviation of theta divided by theta bar. How much is something that's telling you how much are the fundamentals that are generating the income inequality spread. The other one is this sigma, which basically think of it as a strength of the social preferences that are, in this case, leading to the redistribution. And in more general models, what are the general equilibrium effects of taxation? In other words, how sensitive are some aspect of the deadweight loss and the factor prices and good prices to the introduction of theta. This is not in our model, but it's going to be important. When thoughtful economists on the left and on the right disagree about optimal tax policy, they tend to disagree not because of this, because the data here is very straightforward. No, so it's not about distribution of income, but about what is the underlying model of the economy that best describes the economy, what are the true equilibrium effects, or what is the objective function that should be used. Some people, for example, extreme libertarians, will think that social preferences should not be there. Others, which will tend to lead them to very low tax rates for redistribution purposes. People in the opposite of the spectrum will have a sigma, for example, in this formation of the problem that is very large, we would push the optimal tax high. I hope that you have enjoyed this section on the optimal labor income tax, not because I think it's the most important topic in economics, although I think it's an important one and a beautiful one, but because it should really give you a feeling of the power of economics to answer complicated questions like what should be the optimal tax rate, and also of the amazing progress that you have made over the last few weeks from nothing to the ability to really understand how economists can, and the power of the method of economics can be used to formulate these questions, come up with a precise answer, and an answer, more importantly, that links to empirical parameters.